Hello everyone, I am Professor Sahebgouda Patil, Department of Computer Science and Engineering, BLDEACET, Vijaypura. I welcome you all for this cloud computing lecture. So in this lecture, we'll see the following contents. So we have the contents that is workflows, coordination of multiple activities. Then we have safety and liveliness. Then we have workflows, basic workflow pattern. So we have three content here, as I told you, that is workflow coordination of multiple activities, safety and liveliness, and basic workflow patterns. So we'll see what do you mean by workflow. So many cloud applications that require the completion of multiple interdependent tasks. So the description of a complex activities involving such an ensemble of tasks is known as workflow. So this is how we can define the workflow. So next we discuss in this particular session, that is workflow models, the life cycle of a workflow, then the desirable properties of a workflow description, so workflow pattern. So we are going to see the pattern of the workflow, then reachability of the goal state of a workflow, and dynamic workflows, and conclude with the parallel between traditional transaction system and a cloud workflow. So these concepts we are going to learn in this particular session. So next we have some of the terminologies, that is a task. So what do you mean by task? The task is the central concept in workflow modeling. A task is a unit of work to be performed on the cloud. So what do you mean by task? It is a work to be performed on the cloud, and it is characterized by several attributes. So the task can be characterized by several activities such as name, description, actions, precondition, post-condition, and attributes. So we'll see one by one. So what is name here? Okay. So name is a string of a characters uniquely identified by the task. What is this name? It is a string of characters that is uniquely identified by the task. So next we have the description. So description, it's a natural language description of the task. So it's a natural language description of what? Task. So next we have actions. So action means it's a modification of the environment caused by the execution of a task. So that is how we can define the action. So next we have precondition. So precondition means it's a Boolean expression that must be true before the action of the task can takes place. So that is precondition. So coming to the post condition, it's also Boolean expression that must be true after the action of the task takes place. This is before and this is after. The next we have the attributes. So attributes, it provide indications of the type and quantity of resources necessary for the execution of the task. So this is called it as what? Attributes. So these all are terminologies with respect to the task. Okay. So next we have a process description. So what do you mean by process description? So process description means it is also called as a workflow schema. Okay. Process description can also be called workflow schema. So schema diagram we have studied in database management system. So it is, sorry, okay. So process description is a structure describing the tasks or activities. So what it does, it describes the task or the activities that is to be executed and the order of their execution. So it gives the order of their execution and the task that is to be executed. So it resembles flowchart. The flowchart term we have seen in the basic C programming concept. Okay. So this process description, it resembles the flowchart. So next The flowchart means you know that flowchart description resembles workflow description resembles flowchart. It's a concept we are familiar with the from the what programming, that is C programming. Okay, so next we have case. So what is this case? So case is an instance of a process description. What is this? It is an instance of a process description. The start and stop symbols in the workflow description enable the creation and the termination of the case respectively. So start symbol means what? It is a beginning. Okay. So stop symbol means what? It is the termination of the process. Okay. So this is the terms with respect to the case. The next we have state of case at time t. Okay, so state of case at time t is defined in terms of task. So this is defined in terms of what? Task. So this is already completed at that time t. That is why we call it as a state of case at time t. So next we have events. It causes transition between the states. So there we have the states, two states, the transition between two states that is caused by, that is called it as a event. Okay. The next we have the life cycle of a workflow. This is the last one. Life cycle of workflows. In this, we have the creation, definition, verification, and enactment. It is similar to the life cycle of a traditional program. So it is similar to the life cycle of traditional program. So that is creation, compilation, and execution. Creation, compilation, and what? Execution. Okay. So this is all about the workflow. So next we'll see a workflow diagram. So this particular diagram, so which talk about the parallel between workflow and the program. So this is, just look at the figure here. This is workflow and this is the program. A parallel between workflow and the program. So the figure A, which talks about the life cycle of a workflow. So what is this? This is a life cycle of workflow. But workflow. What about diagram B? So this talks about the life cycle of a computer program. Okay. So this talks about life cycle of computer program. Okay. Just look at this, the similarity between these two, life cycle of workflow and life cycle of computer program. The life cycle of computer program, you people are already aware of this. So here we have the static program and dynamic program. The static program is related to the static workflow. Dynamic program is related to the dynamic workflow. We have the programming languages here. We have the workflow description languages. So users in the both the flow, and we have computer program, that is we have for the computer program. So workflow description. So mainly here with respect to the computer program, we have compiler. You know what do you mean by compiler and how it works. And with respect to the life cycle of workflow, we have verification engine. Then object code will be there to run the code, to run the like sequence of instructions. So here we have the workflow description, and the processor running in the process, it is similar to the enactment engine in the life cycle of the workflow. So this is the similarities. So we'll see that similarities, that is the workflow definition is analogous to writing a program to a program. A planning is analogous to a automatic program generation. So coming to the verification, so verification corresponds to synthetic verification of a program. Verification, it is corresponds to synthetic verification of a program. Workflow enactment mirrors the execution of the program. It mirrors the execution of the program. It's a static workflow corresponds to what? Static program, as I told you. Just look at here, the static workflow, it corresponds to static program, dynamic workflow, which corresponds to dynamic program. So this is the like similarity between the workflow and the program. So next we have safety and liveliness. So here, among the most desirable properties of a process description, so we have there are safety and liveness. Okay, this safety and liveness process, informally, safety means that nothing bad ever happened. So what do you mean by safety? Nothing bad ever happened. And liveness means that something good will eventually takes place. Something good will eventually takes place. Should a case based on the process be enacted? So not all processes are safe and live here. So the processes which are there, so not all the processes are safe and live. So here we have the some of the example for the processes which are not safe and live in the further slide. Okay, just look at the diagram here. The diagram A, focus on the diagram A. Okay, what it says, it's a process description which violates the liveness requirement. So we were talking about safety and liveness. So this is an example for where which violates the liveness requirement. So how it violates? Here, if a task C is chosen, okay, here if task C is chosen after completion of B. So after completion of the task B, we are going to choose the task C. The process will terminate after the task G. So here what happens? This process will terminate after the what? Termination of executing the task G. If D is chosen, suppose if D is chosen, what happens? Then F will never be instantiated because, so when we choose the D, it is not at all related to the F. So F will never be instantiated because it requires the completion of both C and E. So here when we choose the D, C and E supposed to be what? Complete the process. Okay, so the process will never terminate because G requires completion of both D and F. Have you understood? So here the process, okay, the process will never terminate. Why it is never terminate? Because G requires what? Completion of both task D and task F. Okay, so this is what violating the liveness. Coming to the figure B. Okay, just look at the figure B. What happens here? Task A and B need exclusive access to two resources. So this is task A and this is task B. So they require the what? Resources. So exclusive access to two resources. What are the resources? R and Q are what? Resources. Okay. And deadlock may occur if the following sequence of event occur. So you know what we mean by deadlock. Okay, deadlock concept we have gone through in operating system. At time t1, what happens here? A task A requires resource R. Okay. At time t2, okay, at time t2, task B requires resource Q. Okay, and continue to run. Then at time t3, task B attempts to acquire resource R. Okay, listen carefully. At time t3, task B, that is attempt to acquire the resource R, and it blocks because R is under the control of what? Task A, because it is acquired by task A. Okay, task A continue to run, and at T4, what happens? Task A attempts to acquire Q, which is already acquired by whom? Task B, and it blocks because Q is under the control of what? B. So Q is under the control of D, but task A would like to acquire this resource. Okay, in this case, what happens? What happens? So deadlock happens. Deadlock happens. Okay, so this is a one of the example for what? A violation of the liveness. Okay, so next we have basic workflow pattern. So basic workflow pattern. So just look at this figure, the basic workflow pattern. So in this, we have the cases like case A, B, C, D, E, F, G, H, I, J. Okay. So till here we have the cases. So we'll see one by one. Okay. The first one, basic workflow pattern, is a temporal relationship among the tasks of a process. The first one is sequence. Okay, sequence means several tasks have to be scheduled one after the completion of other. It means that after completion of one task, we are going to have the another task. Look at the first figure, task A. After completion of task A, then we have task B. After completion of task B, then we have task C. Okay, so this is what example for the sequence. Okay, example for the sequence that we have seen in this particular diagram. So next we have the AND split. Okay, so both task B and C are activated when task A terminates. Okay, look at both task B and C. Okay, task B and C activate when task A it terminate. So that is what call it as a AND split. Okay, so this is the symbol for what? AND split. Okay, so next we have the third one, synchronization. So synchronization means what? Task C can only start after the task A and B terminate. Okay, so listen, the third one. So the task A and B should terminate first, then only the task C will start. So this is an example for what? Synchronization. Next, we have XOR split. Okay, so what XOR split does? After completion of task A, either B or C can be activated. Okay, first task A has to be complete. Listen, after completion of task A, XOR is there. Okay, either B or C will be activated. So this is what we call it as a XOR split. Then we have XOR merge. Okay, in XOR merge, task C is enabled when either A or B terminate. So when either A or B terminate, then class C will be activated. So this is an example for the XOR merge. We are going to merge the task. Okay, merge means combine. Then we have the OR split. OR split means what? After completion of task A, one could activate either B or C or both. Okay, so this is a OR split. Just look at this. Okay, so what is that OR split? That is, here we have the OR split. Okay, so OR split. So here after completion of this, either B or C or both can be activated. So next we have multiple merge. So multiple merge. So in this multiple merge, what happens? The one task terminates, that is task A. Sorry, once task A terminates, B and C execute concurrently. In multiple merge, what happens? Once task A terminates, B and C that will execute concurrently. So how we can see this? When the first of them, say B terminates and then D is activated. Okay, when B terminates, what happens? D is activated. Just look at this here. When B terminates, D is activated. When C terminates, what happens? D is activated again. Okay, when C terminates, okay, when B terminates, D will be activated. When C terminates, again D will be activated. So this is what? This is multiple merge. Then we have the discriminator. So what do you mean by discriminator? It waits for a number of incoming branches to complete before activating the subsequent activity. So then wait for the remaining branches to finish without taking any action until all of them have terminated. So next it will be reset. Just look at this diagram. So in this H, okay, all of them, this is a discriminator, okay. So discriminator, what it does here, AND operation is there. So B and C. So B and C, what it has to do? It has to terminate first. It has to complete before activating the subsequent activity. So before activating subsequent activity, so the branch has to complete, okay. Then wait for the remaining branches to finish without taking any action until all of them have terminated. This is the example for discriminator. Then we have the N out of M join. Okay, so what do you mean by this? Here the barrier synchronization, assuming M tasks run concurrently. Okay, so N means if it is N less than M, of them have to reach the barrier before the next task is enabled. So in our example, any 2 out of the 3 tasks A, B, C have to finish before E is enabled. Just look at here. So any B, C, D have to complete before A is enabled. This is an example for what? This is an example for the N out of M join. And the last one, deferred choice. Similar to the exhaust split. It is similar to the exhaust split, but the choice is not made explicitly. The runtime environment decides what branch to take. So this is an example for what? As I told you, it is similar to the exhaust split. Okay, so this is an example for deferred choice. So hope you have understood all this parameter with respect to the basic workflow. So these are the patterns with respect to basic workflow. So thank you so much for patient listening. If you like this video, please like it and subscribe the channel, share the video. Thank you so much.